Welcome everyone. So today let's study a new concept, that is black hole, related to black hole. Now let's study what is a black hole. Student, a black hole is a region of space-time where gravity or gravitational force is so strong that nothing, no particle or even electromagnetic radiation such as light can escape from it. So this is a region in a space from which no particle can escape from it. That is a black hole. And the strong gravity occurs because matter has been pressed into a tiny space, and this compression can take place at the end of a star's life. So we have already discussed in our one of the video related to the life cycle of a star of standard 8 that end stage of one of the end stage of the star is nothing but the black hole. Okay, and some black holes are a result of dying stars. That means the end stages of the star is black hole. Alright, now what is a black hole? So because no light can escape, black holes are invisible, and however space telescope with special instruments can help find black holes, and they can observe the behavior of material and stars that are very close to black holes. Alright, so how big are black holes? Student, black holes can come in a range of sizes, but there are three main types of a black hole. So the black hole's mass and size determine what kind it is. So according to their masses or sizes, different three main types of a black holes are there. So first is the smallest ones are known as a primordial black holes. So the smallest one or the primordial black holes scientists believe this type of a black holes is as small as a single atom but with a mass of a large mountain. And the most common type of a medium sized black hole is stellar. And the mass of the stellar black hole can be up to 20 times greater than the mass of the sun and can fit inside a ball with a diameter of about 10 miles, and dozens of stellar mass black holes may exist within the Milky Way galaxy. So this is a second type of a black hole. And the third or the largest type of a black holes are called supermassive black holes, and these black holes have masses greater than 1 million suns combined and would fit inside a ball with a diameter about the size of the solar system. And scientific evidence suggests that every large galaxy contains a supermassive black hole at its center. And the supermassive black hole at the center of the Milky Way galaxy is called Sagittarius A. So this is Sagittarius A. This is a kind of a supermassive black hole, and it has a mass equal to about 4 million suns and would fit inside a ball with a diameter about the size of the sun. So here I have I am putting a pictures of three different types of a black hole. So first is a primordial black hole, which is the smallest type of a black holes, and the second is a medium type of a black hole, that is stellar black holes, and these are the massive supermassive black holes, that is Sagittarius A black holes. Alright, now how do black holes form? Let's see. Alright, so primordial black hole, which are the smallest type of a black holes, are thought to have formed in the early universe soon after the Big Bang. And stellar black holes form when the center of a very massive star collapses upon itself, and this collapse also causes a supernova or an exploding star that blasts part of the star into space. So supernova it has a very high temperature and a pressure. And scientists think supermassive or Sagittarius A type black holes form at the same time as the galaxy they are in, and the size of the supermassive black hole is related to the size and mass of the galaxy it is in. That's why it is known as a supermassive black holes, because it has a mass highest as the galaxy. Alright, now here let's answer one question. If black holes are black, then how do scientists know they are there? Alright, so a black hole cannot be seen because of the strong gravity that is pulling all of the light into the black hole center. As you all can see alongside picture, in the center it is a black. And however, scientists can see the effect of its strong gravity on the stars and gases around it. So you can all observe around the black hole there are that is a strong gravity on the stars and gases which are there around the black holes. So scientists can see the effects by it. And if a star is orbiting a certain point in space, orbiting means a star is orbiting around the black hole in the space, scientists can study the star's motion to find out if it is orbiting a black hole. And when a black hole and a star are orbiting close together, high energy light is produced. And scientific instrument can see this high energy light when a black hole and a star are orbiting close to each other. Together, close together. Now, next question. Could a black hole destroy our Earth? No. Many believe black holes go around in space eating stars, moons and planets. And scientists have debunked this perception. So, this is just a perception. And Earth is facing no threat because no black hole is close enough to the solar system for our planet. And according to the NASA, even if a black hole the same mass as the sun replaced the sun, Earth still would not fall in. And instead, Earth and the other planets would continue to orbit the black hole as they currently orbit the sun. So our planet Earth is safe from black hole. Alright, will the sun ever turn into a black hole? Stars like the sun just aren't massive enough to become a black holes. And instead, in several billion years, the sun will cast off its outer layer and its core will form a white dwarf, a dense ball of a carbon and oxygen that no longer produces nuclear energy, right? But that shines because it is very hot. And the typical white dwarf is about as massive as the sun but only as big as Earth, which is 1% of the sun's present diameter. So student, I hope this little information about black hole will help you all.